All right, everyone, so you've gotten pretty good at differentiation, which is all about finding the rate of change. Well, today, we're going to unlock a brand new superpower in math, one that does the exact opposite. Let's jump right into the world of integrals. Okay, just imagine for a second you have a YouTube channel, and you know it's growing at, let's say, 100 subscribers every single day. That's the rate of change, right? But the big question is, how many subscribers do you actually have in total? To figure that out, you need to work backwards from the rate to the total. And that is precisely what integration helps us do.
So, before we get our hands on this new reverse superpower, let's do a quick recap of the one you've already mastered: differentiation.
Think of differentiation like this. It's your forward button. If you have a function that tells you the total journey of a car, differentiation will tell you its exact speed at any single moment. It looks at the big picture and tells you what's happening right now. Okay, so now for the reverse. What if you knew the speed of the car at every single moment, but you wanted to know the total distance it traveled? What if you know your daily new subscribers, but you want to find your total subscriber count? This is where integration becomes our hero. Now, the main idea behind integration is finding something called an antiderivative, or sometimes it's called a primitive. And the definition is actually super simple. A function, let's call it capital F of x, is an antiderivative of another function, small f of x, if the derivative of capital F of x gives you small f of x. See, it's just the reverse of what you already know. So here's the most important thing to remember. Integration is simply the inverse process of differentiation. That's it. If differentiation is the forward button that finds the rate, integration is our rewind button that takes us back to the original function. And you know, this amazing idea isn't new at all. It was developed centuries ago by brilliant mathematicians like G.W. Leibniz. They needed it to solve really important problems in science and geometry. So what we're learning is built on a very powerful foundation. Now, I know what you're thinking. This notation looks a little scary, but trust me, it's easy once you break it down. This long S symbol just means integral of. The function f of x, which is inside, is called the integrand. That's just the thing we're integrating. And the dx at the end, it just tells us that x is our variable. Think of the integral symbol and the dx as two parts of a whole bracket. Okay, now we need to talk about a very, very important part of integration. This is something that confuses a lot of students at first, so let's clear it up right now. It's the mystery of the plus c. Why isn't there just one single answer? Let me ask you a quick question. If I tell you that the derivative of some function is 2x, what do you think the original function was? Just take a second to think about it. I'm guessing you thought of x squared, and you're absolutely right. But what about x squared plus 10? The derivative of that is also 2x. Or what about x squared minus 5? Yep, also 2x. In fact, the derivative of x squared plus any constant will be 2x, because the derivative of a constant is always 0. And that, my friends, is where the constant of integration, or plus c, comes in. It's our way of representing all of those possible answers at once. The answer isn't just one function. It's a whole family of functions that are all parallel to each other. Let's go back to our YouTube example because it makes this super clear. Knowing you're gaining 100 subs per day tells you the growth rate, but it doesn't tell you how many subs you started with. Did you start from 0, or did you already have 10,000? That unknown starting number, that's your C. You know, the entire field of integral calculus was basically created to solve two major kinds of problems. And because of that, we have two different types of integrals we need to know about. Okay, let's put them side by side. On the left, we have the indefinite integral. Its only job is to find the antiderivative, so its answer is always a family of functions, f of x plus c. But on the right, we have the definite integral. Its job is totally different. It finds the area under a curve between 2 points, a and b, so its answer is always a single number. The big giveaway is the notation. See those little a and b on the integral sign? Those are the limits of integration.
All right, that was a pretty quick introduction, I know, but let's recap the most important things that you absolutely have to remember from this.
Here's your integration starter pack. Number 1, and this is the biggest one, integration is the inverse of differentiation. Second, an indefinite integral gives you a whole family of functions, which is why you must include the plus c. Third, a definite integral gives you a single number, which is usually an area. And finally, a little pro tip for you, you can always check your indefinite integral. Just differentiate your answer and you should get right back to the original function you started with.
And don't just take my word for it. Your own NCRT book says it perfectly. The whole reason this chapter exists is to solve these two main problems: finding a function when you know its derivative, that's the indefinite integral, and finding the area under a graph, that's the definite integral.
So, there you have it. You now officially have the rewind button in your math toolkit. You can go from a rate of change all the way back to the original total. Just think about all the incredible problems you can solve now, in physics, in economics, in so many fields. Keep that curiosity fired up as you dive deeper into this chapter.